Welcome, dear guests. Good to see so many of you here in the public forum of Hydrogen Fuel Cells Europe here at the Hannover Messe in 2023. We still have a few of the super comfortable seats available in the front, second row. Also some available seats less comfortable, but you also have access to drinks on the house, so you're never really losing actually. So I would suggest to definitely pick one of those seats. And another good reason to pick this seat is because we have an interesting topic we're going to be talking about. And my guest is already here. I'll just introduce the topic. It's the challenge of integrating fuel cell technology into heavy-duty vehicles. And heavy-duty vehicles, that's an application that we're seeing more and more of course. And that makes sense. And why that makes sense is something we'll be finding out rather soon, I think. So from GreenGT, we have the fuel cell and electric powertrain engineer. He's already on stage here with me. Can I please get a warm applause for Matthieu Charrier?
Thank you, Joost.
Welcome. Yeah, get yourself comfortable here. So welcome to the stage. First of all, you've had some time to get comfortable here. You are from GreenGT, and of course, I know GreenGT, and I think a lot of people here know GreenGT. For the ones who don't, can you please give us a small introduction into GreenGT, the company?
GreenGT has been created in 2008, basically focused on a high-performance vehicle for racing. It started with battery, and as you may know, autonomy is a key point on endurance racing, and we straight away noticed that charging the battery was a problem. And then we turned to fuel cell system to have this autonomy and the capability to fill the vehicle in a quick way. And that's the story it started. And we started to make our first car.
Yeah, and I've seen those cars, or that car quite often. And maybe for the regular visitors here of the exhibition, last year, somewhere over there was this white LMP car, the car you see in Le Mans racing, right? It's that
Correct.
type.
Correct. It's a car we have developed for Le Mans racing. So we have developed this car with 45-minute capability full load, so with 240 kilowatts fuel cell, with battery with high C rates, able to perform this Le Mans capability with 45 minutes run, and able to have this quick refill, as it's supposed to be in endurance racing.
Definitely interesting developments and a very different application than you would usually think of with hydrogen, right? But when you tell it like that, it makes sense. It makes sense that for endurance racing you need that quick refueling and you need the power. So interesting development, and you guys were definitely pioneers here. So that's the motorsport. I know GreenGT is also focusing on mobility and infrastructure. I think given the topic here, we're mainly going to be focusing on the mobility aspect. So could you give us an insight into GreenGT's effort with regards to mobility?
We turned from this expertise on high-performance powertrain and how we could handle these high-performance figures. And this experience in powertrain, we turned it in experience in mobility general fields like heavy-duty trucks. And we had customers who requested us how we could handle and help them to turn to this hydrogen environment. And then we had the opportunity to do this with the mobility industry. And then we have also the infrastructure business unit that also help us to see the other side of the problem, how to fill these vehicles. So that's why we close the loop with this expertise. And in the deeper details, this expertise on the powertrain and the trucks allow us to have now, after 4 years, 2 trucks running, one in Switzerland, one in France, and to try now to finalize homologation, to have them running for our customers, and then help next customers to transform those 2 prototypes in serious vehicle.
Amazing, yeah. So I know in 1969, when the first rocket reached the moon, there was a fuel cell on board there, and then we went slightly less high-tech to the race cars, apparently, and now you're applying this knowledge and this experience to other projects too. So my question would be, how can customers, maybe people sitting here, how can they get access to all of that experience you're bringing in GreenGT?
Well, plenty of customers are, let's say, not totally aware of all the constraints of hydrogen field. So they want to turn to hydrogen field. They want to have an expert point of view. They turn to us. And first, we try to help help them, to find the proper way and to select what would be the definition and what would be the specification of their need. They know what are their operational needs, but they don't know how to turn it in technical needs for us as technicians to build vehicles. So we turn all these operational points, we make a specification with us. We could also help them to figure out with simulation tools how to balance amount of battery, amount of fuel cell, amount of energy stored in battery or in tanks with H2. And with all these figures, we are able to help them to make the first step and give them a first prototype or just a first fuel cell system, because we have both capabilities, working on the complete vehicle or only dedicated on fuel cell systems, and able to make any custom studies for them.
So you can basically deliver a system that's as integrated as the customer might need it. A full system, the full powertrain even, you can do it.
Yeah, exactly. So we can work on tanks, battery, fuel cell. And for fuel cell, we can also have a total custom system starting with cells and membrane. We make our whole stack by our own. We have all the capability to make the whole balance of plant around with the proper compressor, the proper humidifier, all the components, and to make them a complete system answering their questions.
All right, so you already mentioned you start with the requirements, and that makes sense, right? So first you find out what does this customer actually need, and then how do you take that information and deliver a system in the end? Is there some, I'm assuming you're doing simulations, like what kind of capabilities are you bringing in there?
Exactly, we start mainly by simulation to detect with a circular views, if they have circle life, in order to detect what is the average speed, what is the average power, what is the maximum power, how we can use what is the altitude requirement, because all these parameters have a deep impact on the fuel cell system design, on the balance of energy between battery and fuel cell also, and also the autonomy, because it have a deep impact on the volume that will have the final vehicle. Because storage of H2 gas it's complicated according to the existing platform. When you consider so far retrofit, because main of applications are retrofit application, it has a deep impact on the way we will design and we will integrate all the system on board.
Yeah, and you're already starting there indeed about, I was going to ask, that there must be some challenges along the way then, especially when we're talking about these integrations into heavy duty application. You already mentioned integrating the hydrogen storage. That's a challenge. So what are some of the things you need to be thinking about there? Is it just the type of tank, maybe just the volume, or what kinds of challenges are you running into there?
First of all, we need to keep the operational mode of the current customer. So they have a payload or volume to move. So we need to pay attention on how to install this system to avoid any, let's say, loss of operation on their side. And then we try to find the proper storage mode, gas, 350 bar, 700 bar, liquid, or we can speak about anything. So far, the state of art is roughly 350 and 700 bar. But for some advanced project, we are already thinking on liquid, and we are working with liquid storage systems and suppliers.
Yeah, and I can imagine that has massive implications for the full system, of course, whether you go for a liquid or for gases.
Yeah, and that's why also our colleagues from infrastructure business also are there to help our customer to consider all these points, because having this vehicle running is a point. Having it refilled properly in a proper time with a proper amount of gas or liquid is definitely a key point to use this vehicle at the end.
Okay, so that's the first challenge then, integrating that hydrogen storage. We've been talking about this before, of course, and another important point you mentioned there was defining the architecture. right? You know the requirements, you know about how you're going to do the hydrogen storage, and then we're going to be talking about that architecture. What does that entail? What options do you have there?
The architecture will mainly be focused on the balance of battery and fuel cell, and then how you put them in the vehicle, because some will have an impact on operation, on maintenance, on how also to afford a good cooling capability, because cooling will have also, we will see it later, that it has a deep impact on how to install and how to prepare this vehicle. So all this question of architecture are ready to be considered at the very beginning. Otherwise, you might feel like some key points have not been considered and will be definitely a problem.
All right, so then we got the architecture ticked off there. And you already mentioned here thermal system, that's also challenging. Can you tell us why is the thermal system of a hydrogen fuel cell powertrain so, maybe even more difficult than in a traditional internal combustion engine?
As, let's say, a fuel cell system will work roughly like an internal combustion engine. You have a fuel system, you have an air loop, you have a cooling system. And the fuel cell system, to work in a good condition and an efficient way, has to be fed with a proper amount of air, at the proper pressure. And this is something we have to be, let's say, really sharp on design. Because depending on the use, if you use it on sea level or automotive way, or if you want to go at high altitudes, like 2,000 or 3,000 meter high, then you will need a pressure ratio totally different. And then this will have a deep impact on the compressor by itself, and the way you will have efficient or not. So choosing one-stage compressor, two-stage compressor, one compressor with a turbine, all the efficiency impact on the key point and the function, the behavior of the fuel cell will be there. Choosing the proper part to adapt with the proper system.
Yeah, that makes sense. And I also think because fuel cells, of course, run on a much lower temperature than these internal combustion engines, that also has an impact on cooling efficiency.
Clearly. At first point of view, we could say, okay, it's nice to see that we have something working only at 75, 80, 85 degrees. Let's say it's fine. No risk of heat or anything like this, it's fine. But the big impact is on cooling system, because the difference of top pressure compared to an internal combustion engine will allow only less amount of power to be exchanged and will have a big impact on the way we are able to cool our systems.
Yeah, and I keep hearing this over and over again. So must be a big problem then. Okay, so we got the hydrogen storage as a challenge. We got the architecture is defined. The thermal system is designed and checked off. What's left then? You need to pick your components. How do you go about that in GreenGT?
We are a company independent with all suppliers. We are able to find one other supplier matching our needs depending on one of the other points. So DC-DCs, compressor, sensors, actuators. We are able to find what the customer needs with his requirement. Sometimes they will have impact because they have partnerships already in place with one or the other manufacturer with national needs to work with his in-house, let's say, competencies. So we have to adapt on this point, and we are really open, and we have the capability to work with worldwide manufacturers and suppliers for this point.
All right, so because you do that full powertrain, you can really pick a fuel cell here and a compressor there, and what is the value of that for the customer then? What does the customer get out of that, this independence you're describing?
Because this expertise is being able to build the best system with the most efficient system all over the point of the fuel cell system or the vehicle or any subsystem like battery storage, fuel cell storage, and then to build the most, let's say, efficient system on all points to match this requirement.
Yeah, you're really looking at it from a full powertrain, full system perspective, I think, and that I can imagine that that's good for customers. And speaking about those customers, or at least potential customers, I'd like to open up to the audience here. Is there any question? If you do have a question, feel free to raise your hand, and I will come find you with my microphone. There is a question. All right.
how do you see the H2 ICE combustion engine? Do you see it as a kind of competitive technology in this heavy-duty application? How do you see it?
We clearly see as a competitor, but so far, we also see them as partners, because we definitely also need them to have the network of distribution being there. For some manufacturers, it will be easier to turn from diesel or gasoline engines to hydrogen internal combustion engines. And this will allow us to have access to a network. And we might have a different interest. It will be maybe easier to turn some big companies to internal combustion engine, but they still face problem with pollution. They do not emit any CO2, but there is other things that are not still handled properly for internal combustion engine that are covered by fuel cell system. So both will exist, and if they join on the same wheel of going on the market, we'll have a better network, so it will be, for both sides, benefits to go on the market and to have a better network, so a better capability to introduce the market.
All right, thank you for that question. If someone else still does have a question, feel, oh, already, look at that. Loving the audience.
You mentioned maintenance. What is important for maintenance from the architecture point of view?
Let's say, compared to internal combustion engine field, there is far less maintenance need. As you may already know, as battery cars or battery vehicle, the level of maintenance has clearly decreased. We still have some dedicated points to survey on fuel cell system, but the maintenance is clearly lower than internal combustion engine.
All right. I also have a question. We're here with quite many people watching, I would say. There's a whole fair full of professionals. You are here with a booth. You're clearly interested in finding potential partners, finding potential clients. So what is the profile you're looking for here? Who are you hoping to find into your booth after this talk? Who should come visit you?
We are clearly looking for two profiles. First, customers, because let's say some OEM manufacturers for bus, trucks, whatever mobility systems they may need, come to us because they want to turn to hydrogen, and they want to find an expert able to help them for integration of H2 system. We are the one. And the second point is suppliers, because if you want to be aware of existing technology, up to date, for the dedicated points, DC-DC converters, sensors, actuators, dedicated to H2 fields for sometimes. We clearly need you to come to us, say, okay, we exist, we still have no contact with you, we would be interested to get in touch with GreenGT and see how our products could help you, and we'd be pleased to do so. Please come to our booth, and our colleagues for sales, for technical side, for supply chain, we will be there to answer you.
All righty, well, you're hearing it, booth, what is it, B13, right over there. I think with this system level independency, you are opening the door to so many potential partnerships. So I can imagine that this is really something everyone should hear. And then the last question for me, if these people make their way to your booth, what are they going to find there? Except for you, of course.
Sorry, I didn't catch you.
What will the people find on your booth? I know there's a system on display there. Is this one of
Yeah, you will first see the NGT system, so our fuel cell system. So in a few words, 75 kilowatt net, 140 kilograms, ready to be installed. So you will see it in front of the booth, and then you will see our colleagues, and then feel free to have questions, and we'll be happy to answer you for all questions you may have.
Perfect, thank you so much. And I should add to that, there's also chocolate there, quite good chocolate. So that's another reason to go to booth number B13. All right, Matthieu, thank you so much for your time and for your interesting talk. I really enjoyed it. I hope you did too. From the audience, I'd like to ask a warm applause to GreenGT.
Thank you all. Thank you, yes.
All right.